Hello everyone, in this video we'll be seeing what are compound sun and planet gear trains, and we will be discussing a problem for that case also. So in last video we have discussed, you can see in this figure, this is the symbol sun and planet where you are having this sun gear at the center and this was the planet gear, and finally this was meshing with the annulus or ring gear. This we have seen in the last video. Here the planet gears will be compounded. Compounded means in a shaft more than one gears are coming. So here you can see this is a compound gear. So this is compounded, you can see. Here also there will be a central gear which is known as sun, and this will be meshing with the green gear. And in the green gear and this red gear are coming on the same shaft, so they can be said as compounded. And this red gear is finally meshing with the ring gear or the annulus gear. So such a gear train will be known as compound sun and planet epicyclic gear train. You can get a better understanding by seeing the sketches of this compound epicyclic gear trains. So the same compound epicyclic gear trains can be represented in this way. So here at the center you are having the sun gear, and this blue or the central sun gear is meshing with this green gear. So this is the first planet. So this is the planet gear, you can call it as, if the sun is A, here the planet A is meshing with the B, and the red gear, that is C I am naming. So B and C are coming on the same shaft, so they can be said as compounded. And here at the outer you are having the annulus or the ring gear, annulus or ring gear it is, and this is having internal teeth, and this yellow annulus is meshing with actually at this point or at this surface. So this C and say the annulus be D. So A meshes with the B, B and C are compounded, and finally the gear C meshes with the annulus D. And here the centers of the sun and planet or the compound planet are connected by this so-called arm. So here this will be representing the sun, and this will be the compound gears, compound planet gears. So these are the compound gears, and finally this is the ring or annulus. So here there is meshing between this one, and here there is meshing between the sun and planet, and finally this is the arm. So you can understand in a better way by seeing these sketches. In problems these kind of sketches may be given, or simply the description about the gear train will be given and you have to draw accordingly. So in that case you can represent that gear trains in this way. So now we will be seeing a problem from the compound gear trains. So here details about the compound gear sun and planet gear trains are given. Here you can see in this figure, this is the sun gear, that means I will be showing here. So this gear is the sun gear, and they have named it as C, and this C is meshing with a gear called D, and D and E are compounded. So whatever be the speed of D, that same will be the speed of E also. So the compound gears are D and E, so their speed are same. So here in this figure you can see this is the sun, and the sun is meshing with, sun is named as C, and C is meshing with the gear D. So the C and D are meshing, and this D and E are compounded. So this D and E are compounded, and finally you can see here in this figure there is an internal gear or the ring gear or annulus which is having internal teeth, that is meshing with the gear E. So between E and E there is a meshing, that is known as, this gear is known as ring gear or annulus. So for this one we will be using the tabular method of analysis for finding the velocity of different elements. Then here it is mentioned that condition, the annulus or the gear G, the outermost gear G is fixed. So that is a boundary condition, and also the shaft A is rotating at 110 rpm. Here direction is not mentioned, so we will be taking that direction in clockwise direction. So based on this we will be formulating the table for this gear train. So here you can see the table which is required, and in right side you are having the figure. So this is sun, this is the compound gears D and E, and the outer there you are having the ring, and the centers at the centers of compound gears and the sun are connected by the element called arm. So we'll be having the table where first column is giving you the condition of motion, and next we are having speed of elements. Here basically 5 elements are there, but since D and E are compounded, a single column will be required for this one. So in first we will be using this arm will be represented in the first column in speed of elements. Then the central sun C will be coming, and C is meshing with the gear D, and D is compounded with the E, so they will be having a same speed. And finally the gear E is meshing with the annulus G. So based on this one, we will be giving the condition of motion and filling this table. So first always the arm will be fixed. So arm is fixed, and the gear C will be given rotation. So C rotates at plus 1 RPM. Plus 1 RPM means we are assuming a clockwise rotation of at a magnitude of 1 RPM. So because of this one, you can take it as plus 1, and based on this you have to calculate the speed of other elements. So before that we have to count the number of teeth. For we'll be seeing the question again. So here it is mentioned that the number of teeth on different gears, the gear C, that is the number of gears on C is given, which is 50, and the D has number of teeth of 20, that means TD equal to 20, and E has 35 teeth, that means TE equal to 35. And here we have to calculate the number of teeth that is coming on the ring gear or the gear G. So we will be evaluating that first. So if you are seeing here, you can get the radius of this internally the ring gear, that means this will be the radius of this gear, and that you can call it as RG, and this can be obtained from the center of the sun gear. This distance will be equal to RC, radius of sun gear, and this distance will be equal to RD, and finally from up to this point this distance will be equal to radius of the gear E. So from here you can write the distance RG equal to RC plus RD plus RE, and same thing, radius can be converted into diameters. Then diameter of G will be equal to DC plus diameter of D plus diameter of E, and you are having diameter can be represented in terms of module into number of teeth. Here since C is meshing with the D, and the D and E is mounted, and here we are assuming that the same module. So it is an assumption. So assumption is that module is same for all gears, because the module of C and D should be same, and E and G should be same, because they are having a meshing with each other. And here we are also assuming that modules of C and D and E and G are all modules are coming same. Then you can write DG as M into TG, and this is equal to M into TC plus M into TD plus M into T. Since all modules are same, you can get TGS. If you are simplifying, module all M will be getting cancelled, and finally this will be getting TC plus TD plus T. That means this is the sum of this number of teeth. Then you will be getting the number of TG, or the number of teeth on GS, 105. This is the number of teeth, and this will be required when you are completing the table. So here we will be filling the right side based on the first condition. Arm is fixed means the speed of this element arm will be 0. Here sun is given a clockwise rotation, so this speed should be plus 1. And if you are observing, when the sun is rotating clockwise, the gear D, which is coming in meshing with the C, will be rotating anti-clockwise. Since D and E are compounded, whenever D is rotating anti-clockwise, E will also rotate anti-clockwise, and E is having a meshing with the G, where G is having internal teeth, so their direction of rotation of E and G will be same. So whenever E is rotating anti-clockwise, the internal gears or the ring or annulus G will be also rotating in the anti-clockwise direction. So here we are having a single column for the compound gears D and E. Since it is rotating anti-clockwise, a minus sign will be given. Now we have to find the magnitude of this speed of this one. So here the gear C and D are meshing. So omega D divided by omega C is equal to TC divided by TD. Here number of teeth on this C and D, all values you are having. So you can write omega D equal to TC by TD into omega c. Here for the first condition of motion, we have assumed that the speed of sun c or omega c is 1 rpm, which is the magnitude. So you can write Tc by Td. Since d is rotating in anti-clockwise, you can have minus sign that we already written here. So this is minus Tc divided by Td, and this will be the same speed of gear E also. So this will be equal to omega E also. Now we will have to write the last column, that is corresponding to speed of the annulus. Here if you are observing, the annulus is making a meshing with the gear E. So you can write omega G divided by omega E is equal to number of teeth on E divided by number of teeth on G. And this you can write it as omega G is equal to TE divided by TG into omega E. So this omega E you can substitute from here, because omega E is same as omega D. So now this will be becoming TE divided by TG into, instead of omega E you can write TC divided by TD into omega c. For the first condition of motion, this omega c value is 1, and remaining terms will be this terms, that is T into Tc divided by Tg into Td, and this sign will be minus, and here also since the annulus or the ring gear is rotating in the anti-clockwise direction. So you can write the last column, which is minus T divided by Tg into Tc divided by Td. So this is the first column, first row, or based on the first condition of motion, and remaining things can be filled easily. So second condition of motion is, here also arm is fixed, so its speed will be 0, and the central gear, that sun, will be rotating at general x rpm in clockwise direction. So you can write it as plus x rpm. Based on this you can fill, this is 0 and this is plus x. We can multiply all terms by x, so this is Tc divided by Td into x, and this will be minus Te divided by Tg into Tc divided by Td into x. And the final condition of motion, this is the final condition of motion that we are going to write. Arm is rotating, and here also we are assuming it is rotating in the clockwise direction. So we will be having plus y is the magnitude, y is the magnitude of the rotational speed of arm c, which is given, and this will also be assumed in clockwise. So based on this you can add this y to all elements. So this will be becoming y, and this is y plus x, and this is y minus Tc divided by Td into x, and finally you will be having y minus Te divided by Tg into Tc divided by Td into x. So this is the final values you will have to require for solving the problem based by applying the boundary conditions given. So this value will be taking to apply the conditions. So here I have listed all the speed of this element. Arm is y, c is y plus x, and this compound gear is this expression, and finally the annulus is this expression. This values we have taken from the last final row of the table that we have formulated, and here we will be applying the boundary condition. Here it is mentioned that the gear G, that is the annulus or the outer ring gear, is fixed. That means gear G is fixed, and based on this condition you can write omega G equal to 0. Then you will be getting omega G is actually this expression. Then you will be getting y minus T by equal T by Tg into Tc by Td into x equal to 0. Otherwise y is equal to Te divided by Tg into Tc divided by Td into x. So this is the first equation that you are getting. And second condition is, here it is mentioned that the shaft A is rotating at 110 rpm. Here shaft A is rotating at 110 rpm means here the sun gear C is fixed to shaft. That means the speed of gear C, that is speed of the central gear C, will be equal to 110 rpm, and we are taking in the clockwise direction, then it is equal to plus 110. And here we are having omega C is having this expression, that is here omega C is represented by y plus x. So the value of y plus x is 110. So you are having this second equation, that is y plus x equal to 110, and this is the first expression. And here all the values of number of teeth are you are having. The number of teeth on C is 50, that was initially given. Number of teeth on D was 20 and number of teeth on E was 35, and we have found the number of teeth on G, which is 105. So all values of number of teeth we are having. From this you can solve for this X and Y, and then we will be getting the value of X as 60 and Y as 50 you will be getting. And then you can find here it is asked to find the speed of the arm. So here we have to find the speed of the arm, and finally the speed of the arm you can find, and that is given by the expression Y. So this will be equal to 50 rpm since it is positive. So this is representing positive, means this will be representing a clockwise rotation of this arm. In a similar way you can find this speed of the compound gear D and E also by substituting Y, TC by TD and X values. So this is the way how you can solve a problem for this compound sun and planet epicyclic gear train. Hope you understood.